Love that bit. Okay, so I'm just going to talk about some news. Reveal the mystery. Well, not reveal. Introduce the mystery item, and then we're over to Jacob, Jacob Calland, for the tour of the FabLab, the main event. Then after that, I reveal what the mystery object is, if you haven't already guessed it. And then it's just a social bit. But I'm afraid, Lee, you won't be able to join in for that because I'm going to end the Zoom meeting for that.
Yeah, that's fine.
Okay. So I'll get a move on with the news. Last weekend, we had a tech club here. And in past meetups, we've talked about the tech club, where it's a free event, normally once a month, I think. And we're trying different things to find out what people want. And last weekend, it's hosted here by the Margate School, thank you. And I came here and did some electronics, kind of practical exercises aimed at kids, and the 3D printing demonstration. I think it went down really, really well. I was constantly busy for just the 2 hours in the morning on a Saturday. There was a software. There's someone in the waiting room. There was a software introduction, a bit of a course, and there was an artist showing some interactive art. If there's something that you think could contribute to the tech club, some kind of workshop aimed at kids, or just a demonstration of technology that will inspire the next generation, Genetic Moo, who are leading this, would be very pleased to hear you from you. That went really well, I think. I don't know if you had any feedback through the Margate School.
Yeah, I think, well, very busy compared to the last one. That was the very first one we had like 80 or 90 people, but it was some holiday. But yeah, I think really picking up and I think initially it was a bit more of a kind of show and tell, and now it's a mixture of some performance and still show and tell. I think it's working on that sort of that.
Yeah.
I think like the same thing that case, I think it's quite easy to get based on come and work on the project. And then
Tim we call it play testing. It was interactive art to try and be a bit experimental and see how it works, and maybe even tweak it line in the event. That was that. So get involved with that. It's really good fun actually. The kids get really excited, and the parents get really relieved. Next. Oh yes, this is a big announcement with the budget that the levelling up stuff, the two big bids that Thanet put in were accepted. So this is beyond the town deal. It's about 20 million pounds. There's another 25 million pounds coming into Thanet. And these are really interesting proposals. Maybe I'll come back to this later on. There's a web page. There's a lot of details about what it is, but Ramsgate, there's a lot of changes. A green campus, and the Smack Boys Hotel is going to become a training centre. They're going to put a town square there and do up the lighthouse and clock towers. And perhaps you would best talk about the Digital Margate.
Yeah, that was built by Kent College, and their plans to take over what used to be M&S motors and stores, with the building, and that's going to be a 16 to 19 I think that's the focus there. I mean, T levels are like the kind of practical A levels. I don't know if you know. It's a bit like a B Tech, but halfway between a B Tech and a but it's kind of practical skills that fall well. That all looks very exciting. There's going to be a big demonstration space on the ground floor of that building for students that demo public, and we school reckon to take up a bit of that building as well and have some more studios and kind of more tailored VR facility. So our plan to do couple, will be that we kind of keep this space as our messy workspace upwards, and then down the road we do work back and do a lot of collaboration between apprenticeships. There's been very exciting. I hope we have some young people trained up and some have some tech skills. Yeah.
Wonderful. Have any of you heard of that at all before?
Well, I think it was only greenlit yesterday, and I mean, yeah, I think probably, and then it will probably not start until September after the conduction of the school year. Before that. I think almost everything will be going on building the course. Coming back as well, so I won't thank you very much. Yeah. No, it's all the money really is all about building out, but also
I'm at the front door.
Oh,
I can go and do that. Sorry,
Jacob's on his way down to let you in.
Thank you.
That's very inventive, Paul.
Couldn't find a doorbell.
Should have been on time though. Come on.
I've been in the New Forest. Get off my case.
How long have you not?
Okay. Right. So yeah, that's amazing. That's a lot of money and some really interesting plans. I've got the web page up. Just I'll have a closer look at the web page right now, maybe. If I do this. So it's all around here. So I think the Smack Boys is that building there, but this is the green campus around here. I hope you can see that okay, Lee.
Yeah.
So the green campus is going to do lots of stuff. The Smack Boys Hotel is going to become some kind of training hotel thing, and they're going to do up that.
No.
The clock house.
Oh, right.
It's going to be refurbished. There's going to be a fishing hub. And that's all. It's very so. Yeah, loads of work experience, apprenticeships. Incredible, actually. I'll send the links to all of you after the meeting. And it's not just in Ramsgate itself. There's Newington. There's going to have some kind of training centre as well. Lots of training. And then there's this Margate Digital. It goes on to as well. Yeah, I think that's absolutely amazing. Yet another bit of amazing news. Okay. And the last bit is my mind's started to think about maybe Christmas party, because Christmas is part of feeling and feeling and that kind of thing. Just wondering if you had any ideas what might be a good Christmas party. My ideas were just to have people like this or maybe at the other end of that spectrum is maybe doing something like an escape room. Margate.
Yeah, disproportionate wandering population.
Anyway, so that is to get you really thinking about what a Christmas party might be like. It could be a little hackathon, maybe.
Yeah, let's see if you can pack the most money. I think we can.
Well, not that kind of hacking, more of a meeting. The other meaning of hacking. Maybe not. I don't know. Or we can ruin Christmas for the people. Anyway, so that's the only news, unless anyone has anything else to add. So now my second favourite activity is the mystery item, and I've got the mystery item right here. Can you see that okay at home?
Yes.
Okay. So this is the mystery object. It's a bit dark here, but the text written around this thing is PK302A. So I just answer yes or no. I can only give yes or no responses to any questions you have now. Yes. I'll reveal what this is in great depth and go down the rabbit holes after the big. Sorry?
Is there an E in this one?
Yes.
Oh, how many?
Yes.
How many?
Yes, they're not.
Yeah.
This is a hangman.
Is it?
So it's not a new age piercing device.
Is it in some way temperature related?
No.
That's another yes.
Is the 180 amps?
No.
Oh.
Ooh, controversial.
Should be 180.
Yeah.
You think so?
They probably meant most things, especially things that size. Any more questions? Nick is waiting in the room. Do you have any questions, Lee, about this mystery object? And hello, Nick. You've just.
No, I think I know what it is.
Oh well, keep quiet.
I have.
Thank you very much. Hello, Nick. You've just arrived. Oh, he's still connecting to audio. If anyone would like to keep it. Oh, Nick's gone. He tried the phone.
Does it have a gate inside?
A little bit.
That's not yes or no. More old school.
Okay. Any other questions?
Is it in any way a transistor?
It's not a transistor, but it is a semiconductor-based device. So that's a yes.
So it's yes, it's sort of.
Is the PK short?
I don't know actually. That's not particularly relevant. The important bit is the IN6302A. That's what you put in to the Google search to get the answers.
Sounds like a really old microphone.
Nope.
Are we meant to
I
give you
love
an
this
answer
bit.
yet?
I love
Are we
this
meant to
bit.
tell you what we
Because I know and you don't.
Well, he does.
And so does Liz.
I'm trying to think why would the connectors be so thick? That's why I thought.
180
Mm.
Yeah. It's got to strike one end, so it has to go the right way around.
Programmable?
No. Okay. Well, you can still think about it. I'll give you another opportunity just before the reveal.
Is it really new as opposed to really old?
No, it's quite old. It's been around.
Quantum velocities.
Actually, it is, weirdly.
It
There
is.
is a quantum related element to this. But
Does it contain?
no. I think me and Lee have the same expression because we know what it is.
Smug. I'm just saying words.
Okay, well, move on. Just but keep that in mind. We'll come back and you'll have another opportunity for glory at the end. Even if you Google that and you're still able to answer the question, you still get.
Oh, really?
So remember the IN6302A might be a good Google for it. But hopefully, Jacob will be entertaining enough to. Okay, so that's the mystery item. I look forward to revealing it. But next is Jacob Calland, Calland, who is the studio and FabLab manager of the Margate School. And we're all here to get a personal or virtual tour.
I'm going to give a little bit of context first before we get going. Like, I'm Jacob. You go first. I've been with the school for 3.5 years. The kind of inception of the school, I think, was in around 2015. A small group of volunteers that worked between Uber, our director's car, parked outside the Sands Hotel, internet connection, and Cafe G at the end of this road. And in 2018, we were in receipt of some funding from a project called Coastal Community Fund, which was a government initiative to kind of, well, similar to Levelling Up, but specifically for coastal towns, which allowed us to start the school. Initially, we started in the centre. We were there for about 6 months doing like professional development and creative technical skills workshops, and then we took this building on, which we'll see a bit of in its glory later. And as I said earlier, this was abandoned for 14 years before we moved in. So actually, when we moved in, you could go halfway down the ground floor of the school. Everywhere else was so full of pigeon food. There was so much airborne pneumonia that you had to wear a hazmat suit and gas mask to get up there. So it's been a real undertaking, and that looks very shambolic still now, and everything we have up here is built out of old doors. But it has come on a long way. I think maybe we haven't put the electrics in on the second floor. So we primarily, our function is as a postgraduate liberal arts school. We run a master's in fine arts, which we're in our 3rd academic year of, and we run a master's degree in visual communication, which is our 1st year of that. We're able to do that because of our collaboration with an art school in France called Estadon, who actually accredit our degrees. The reason that we work with this French art school is essentially all of the universities and higher education institutions in the UK are accredited and overseen the group, and they have quite constrictive regulations how you to run a course. In France, everything is very free and open and kind of fits more in line with our philosophy of teaching, which is project-based and collaborative learning. So, for instance, no one gets a mark until they've completed the end of their 2 years. It's not this time-based, very rigid assessments that go along. And UCA, where Uber used to work, has a assessment guide for the degree show that was like 100 pages thick. And the French have 1 page with 4 sentences on as guidance. So it's very open and allows people to pursue really whatever they want within the umbrella context of the degree. Alongside postgraduate courses, we also have studios and our FabLab, which is all based on this floor. We can have a look at this building maybe later on. We're quite keen that the studio community and the FabLab community is seen as an extension of our teaching division. So everyone who has a studio here as part of FabLab goes to the same guest lectures that the studio holders go to. You have the same access to technical support, and we do business development for people there. So it's sort of a bit like being back within that kind of nurturing learning environment of the school, but while just pursuing what you want. And you can come here and ignore all of that, embrace all of that. Obviously, we like people to be involved with the community we're building, that learning environment, but it's not a requirement. You can come and work by yourself and do your soldering, or become part of this greater community, hopefully. So I'm sure, given all of your interest, the idea of FabLab is maybe quite old, but for anyone who doesn't know what that is, it is FabLab stands for Fabrication Laboratory, and it is a rapid prototyping space using CAD design software and computer-aided machining to prototype your ideas. And it's not a space where you're manufacturing something, although we don't people do run their business from here using that equipment, but primarily it's somewhere to come and test ideas, to see something through from an illustrated drawing to a big sculpture or jewelry, amazing perspex mirrors. Part of the advantage to being part of this network of FabLabs as opposed to being at home with your kit in your bedroom or garage, building ways that there are, I think, 840 FabLabs in the world, and they're all networked together. So we've been able to access the research and the technical support of people all over the world. And it's always, all of these places run on open source kind of ideology. So everyone's always very happy to help each other out.
There's a maker space at the University of Kent.
Yes, I think so. Yeah. Yeah, I think they've got quite similar. I don't know if they're part of that same network. I think
it wasn't there when I was a student.
Right. I mean, what we've found is that the people that have been working here, but they've not known how to do something, it's not been part of the skill set of someone else who works here, that they can go on this website, this forum, this run by all FabLabs collectively, and you end up being paired with someone that knows it in Turkey or something, and that's their specialty. And because it's always kind of quid pro quo, and everyone gets the help that they need, gives the help. You can kind of always find an answer or someone to speak to. We've had one of our studio holders who's just been offered this free tuition here biomaterials in Barcelona, so she's over there for 2 months learning how to make plastic out of algae. And I've been working with a FabLab in Dunkirk called Spark to basically test this idea that I had to take each plastic and turn it into 3D printing. So they have some equipment that allows us to do that, which we're in the process of applying funding to acquire. But before I did it, I wanted to make sure it worked, so I got in contact with this guy who has this equipment, and I say, can you run a load of PET plastic through your, which is very commonly found in our beach, through your machines and see if it's printable filament. So he's done that for me. We're in conversation. Yeah, so it's all very exciting having this big sort of network and knowledge base to pull off. And that's no, right. Oh yeah, of course. There's more. Sorry, they're over there. Yes, so we've got that network also because of our because of us running this art school. We're also part of a group called Elia, which is the largest collection of art schools in the world, and they have hundreds of online conferences. There was a really interesting one the other day about including virtual reality, augmented reality, and theatre performance. I mean, every day there's a conference being run at one of these universities that because of our setup as a postgraduate institution, everyone is involved in the building because they would attend. And that's like a very key distinction for me when we use videos is that, as I said, all of the people who are here are part of that learning program and hold it into that idea and not just people renting a space and working. There is that same support for those people should they want or need it. And that's kind of the background of FabLab and where we're sat. So I think we can go for a little walk. Yeah. So
Lee, I hope the sound keeps working for you.
Yeah, it's a little bit loud when everyone's moving the chairs around, but apart from that, it's pretty much okay.
So yeah, this whole tour of us, we have a kind of permanent studio spaces that can be back and easy to form key group in our FabLab, and then this space is our open office and workbenches, which we have, I think, only about 15 people at the moment who are coming in, on a very part-time basis to work here, but not as a main of them. So the fun side of this floor is making space where we're set up with 3D printing and quite rudimentary work in that. 3D printing, we're in the process in terms of grade, that's very right. Really very good. The thing that's yeah. Yeah. Yeah, that is on 10%. I mean, you can run it again. I mean, well, and you could also get to the end of it. I mean, it's not the late process. I mean, it's something. Yeah, we could get as that's it. So you get that define the we so you can technically find you put it this way, power and speed, the final percentage, and that's how you determine your depth. And then the heavy machine and also achieve stages at grade. But working with this, we really wanted it also to yes, and down the road, but I mean, it does grow. The nice thing, more people have it, then Yeah, I mean, the solvent was quite different. Not really.
Hi, Lee. Did the sound work for you?
No, not very well. It kept coming and going.
Sorry.
But it's fascinating to see the layout of the place. So it's very impressive.
It is. Okay. Maybe, I don't know if we're going to walk around again later on, but the next bit. I'll ask Jacob for a contact thing, but
Yeah, shall I send? You can share my email.
I'll do that in the post-meeting kind of thing.
Yeah.
But the margateschool.com is the website here, which includes FabLab and workbench area there as well. Okay, and there's Jacob's email, jacob@margateschool.com.
And so I should mention that prices on that is for a permanent workspace. So these are the pods here where you can store all your stuff, and there is a £40 membership that you don't have space to be that you have to work take away, or you can have it for your own desk.
Excellent.
Is there like a booking?
At the moment, there isn't, because everyone works in people that are already working here across various disciplines. rarely a big conflict between, and it's quite acrimonious competition between. But the yes, yeah, I think yes. But I think in the future things like the 3D printing we might expect. But at the moment it's been quite short.
How many members?
So we've got 35 permanent people who are here, and then we have 15 people who come and go from this place, and then we also have 30 students at the moment who do make it to this piece, but maybe slightly less than the people who are kind of working over that one. In total, there's about 80 people associated with the building, but across two different pathways. So really varies. We've got a couple of set designers. We've got quite a few fine artists who do this sort of stuff in their practices. We've got architects. Quite architectural visualization, model making. We've got a few people like just painters, a couple of electronics, it's very varied. It's very varied.
Well, thank you very much, Jacob. That was brilliant. I hope the sound recording, apparently it was a bit patchy, so the recording of it might not be very good. Underlines the wonderfulness of in-person meetings and for people that offer to speak, I offer them a unique, ultimately personalised trinket, if you would want one.
Yeah.
So,
Very good.
If you'd like to pass it around to encourage you to volunteer to speak next month, perhaps. Because it's the only way you can get one of those. The only way.
Thank you very much. Pride of place on the fireplace.
Sorry?
Not
Not open source at all. No. No. I was thinking of maybe shrinking it down in Mars by and keep the price the same, but it gets smaller because it takes quite a while to print. But I've decided to maintain the quality.
Yeah.
Okay, so yeah. Right, the next bit is the mystery item. So I'll give you another opportunity to look at the item here. Lee, who is on Zoom, already knows what it is, I think. Don't
Yes, definitely.
But remember the confidence, just in case. Okay. Are you ready for the answer? Or do you have any questions before I go to the reveal? It's not a capacity.
Yeah.
generator.
Made me realise.
I love this. Okay. Oh, yeah, on the right lines there, it is a diode, but it's not a standard diode. Not a photon diode. I mentioned before that quantum tunneling is part of it. Funnily enough. But Lee, what is it?
It's just a dirty, great big diode, power diode.
It's a little bit more specific than that. So I'll give you 5 out of 10 and a tick VG. It is, in fact, look at this, animation. Thank you. hang on, sorry. I think Lee, you missed that. I'm going to have to go back. How can I go back? Oh no. Testing my PowerPoint skills here. Right, I'm going to switch over here. Right. It is animation. It's a Zener diode. Okay, so it is a diode in that it does, when you connect it in the sort of correct direction, it allows current to pass in one direction, but not the other way. That's how a diode works. The Zener diode does that as well, except after a certain threshold, it lets current go the other way, which is weird, because why have a diode that conducts in both directions? But I will get into that right now. This is where I go into my little rabbit hole. I love this bit. So an ordinary diode is like a one-way valve for electronics. So, for example, in this circuit here on the left, you might use a diode so that if someone connects the battery the wrong way round, the current can't flow through that diode to blow up the load, the circuit that battery is powering. Electricity can only flow from the positive through the diode and back to the negative terminal of the battery. And diodes, because of that principle, can be used for something called a bridge rectifier, where you get an AC input, which goes positive, negative, positive, negative. And the diodes smooth that to be just positive, as in a direct current, which is useful for microcontrollers and quite a lot of electronics kind of stuff. AC would fly all that way. AC is great for cookers and fridges and hoovers. It's awful for Raspberry Pis, Arduinos, and that kind of thing. So,
is a rectifier part of most DC adapters?
absolutely.
Yeah. I think I heard of it in the context of my dad had an old train transformer and a rectifier. But nowadays we just think of a plug which does.
Yeah, these things that you plug your computer in to. This is AC coming from the mains, and this is DC coming out of the other side. So, first of all, it rectifies the AC current to be direct, so it's just a positive voltage. The transformer then knocks the voltage down from 230 volts down to a voltage. So quite often you get a rectifier to get rid of the alternating current and make it direct current, and the transformer transforms the voltage to the current level. And so diodes are used in that way. So if AC for 50 hertz, so for the current flows first in one direction and the other, it alternates. And when it's flowing in this direction, it can go through this diode, and then through the circuit, and then back to the other side of effectively the battery. When the electricity alternates to the other direction, it takes a different path through the diode, but it takes the same path through the actual circuit. So you get that direct current, and that's where diodes are used. But this isn't about diodes, this is about Zener diodes. So when you connect it positive to positive, it works just like a diode, but no one ever uses Zener diodes in this way. They use ordinary diodes for that. But if you turn the Zener diode the other way, in a reverse bias, no current can flow through it until it meets what's called the Zener voltage, like a threshold. Then it starts conducting that voltage. And if you increase the supply voltage, it maintains that same voltage on the process. So it's a great way of regulating a voltage, regardless of the input. It won't conduct anything until it reaches the desired voltage, and it won't go higher than that very much. So a Zener diode is a diode that works backwards at a very usable voltage. Like an ordinary diode, if you connect it the wrong way around, if you put 1,000 volts to it, it will break down and start conducting. It will break. But Zener diodes use that same property, but in a useful way. I've got some examples. There is a video here on the that I'll include in the links that I send out later from the awesome EV blog. Anything about electronics, go and watch this. He's got slightly annoying Australian accent, but he's got amazing knowledge and great communication skills apart from that. But I learned a lot from him. So I'm going a bit deep. I do this sometimes. So stop me if this becomes uninteresting. So this is one use for a Zener diode. Okay, so right, this area, the top right quadrant of this graph is when it's connected properly, as in, and it acts like an ordinary diode. So there's a kind of a forward voltage drop of any diode. It's only 0.9 volts normally for diode. But ordinary diodes, as you move left into having the voltage reversed, minus V over here, an ordinary diode, this curve just keeps going and going and going to like minus 1,000 volts, and then it starts conducting, because that drop means the current increases and it's conducting. But a Zener diode, this voltage could be 12 volts, 2 volts. The one that I passed around, that 180A part, is telling you that it starts conducting in reverse bias at 180 volts. So that Zener diode. Oh, well, that's just to confuse you.
Ah, okay,
yeah.
Good. What? Really?
Yeah. So this circuit on the right is a voltage regulation circuit. So this Zener diode here at the bottom is put the wrong way round. So you've got plus volts coming in here, and it's hitting the plus sign of this diode. So nothing should go. If this is an ordinary diode, current would only go this way, but the current is actually flowing this way and goes to the actual circuit. But because that's a Zener diode, when this voltage reaches VZ, it allows the current to flow, and it produces VZ to the circuit. So if that was a 12 volt Zener diode, when V plus was 10 volts, you wouldn't get anything. There would be no current flow, so you'd get 10 volts here. But if this is a 12 volt Zener diode, when this got to 12, you'd get 12 volts here. When it's got to 13, 14, 15, all the way up to 100, you'd still get 12 volts here, because this would allow current to flow and remove the excess voltage from the circuit. So it's a kind of a dirty way of getting a regulated constant voltage, like you do from one of these bricks. That you could sort of get a Zener diode across a live and neutral lead on a mains thing and get 12 volts out of it. Bit dodgy, a bit inefficient. But you can do that. I don't know. Oh, yeah, well, I'll show you that in, I think, because I go even deeper, a little bit deeper. So it's good. It's okay for voltage regulation and getting reference voltages. And it's used a lot in electronics, including chips and that kind of thing. And this circuit at the top here, you can see there's a chain of a Zener diode, an ordinary diode, and 2 more Zener diodes. So you put in voltage of more than the sum of the Zener voltages of all these and breakdown voltage diodes. And so this one is a 10 volt Zener diode. This is an ordinary diode, so that will start conducting at 0.6 volts, like most diodes. This one is a 3.3 diode, and this is a 5.1. All of those added together are 19 volts. So this circuit gives you a 19 volt supply, 13.9 volts, 10.6, and a 10 volt supply. And you can choose different diodes to get different voltages, because circuits sometimes have different voltages. So a feather microcontroller uses 3.3 volts. The XP most that we've been using are 3.3 volts. Arduinos like between, I think, 5 and 12 volts. And Zener diodes are a really nice way, an easy way of getting those different voltage levels in the circuit. A huge use for these Zener diodes are for protecting circuits from under and especially over voltage protection. So this second circuit here, this is a 6.8 volt Zener diode, and if this battery was 5 volts, you would get 5 volts out at that point at the top right, and when you reach 6.8 volts, you get 6.8 volts out. But if that battery gave 15 volts or 7.5 volts, you still get roughly the voltage of the Zener diode out, and that could go up to 100 volts, and it would still be roughly 6.8 volts. So it's just how you could protect the circuit from being plugged in. No, yeah, and you think with that kind of stuff as well. To go a little bit deeper, there are sort of power constraints of the diode, but if it's a transient, like a massive spike to 1,000 volts, it might not fry the diode because it happens very quickly, and the diode won't be able to cope with that sort of spike. So surge protection is a thing that Zener diodes are good at. And I don't know actually. I don't know. So,
I can see them like Zener here,
I suppose putting them in parallel would keep the voltage, but would put the current down. So maybe they do. I'm not an expert at that. And there's AC clipping and clamping, and that's this third circuit at the bottom. They get two opposing Zener diodes. And so if you get, if these are say 5 volt Zener diodes, if you put 6 volts through that, it will clip it at 0.6 volts, because this works like a diode, so there's a 0.6 volt drop over the forward bias one, but the reverse bias one, that Zener voltage would kick in would be 5 volts if you add them together. And the result is something like this. So, in audio circuits, that's quite useful. Or for, again, voltage protection, you can use that in an AC circuit to flip the voltage using the level. So quite useful, and I'm pretty sure there's hundreds of them, especially the circuit protection one and the clipping and clamping. Most useful. So that was the mystery object. Well done, Lee, for getting the closest. And that's my little rabbit hole for the evening. And that's it, really, apart from what's next. Volunteers to speak at the next one, or even come up with the mystery object and go into Roman. Struggle. And yeah, what's next? Don't know. We'll find out. Anything vaguely geeky, technical, really. We've had people talk about game design, radio, amateur radio, um, um, animatronic chimp, autopsy. What is it? What? Dismantled an animatronic chimp's head. That was last month.
Yeah, online.
Online. Well, if the,
It was, yeah. One of you was like moving the camera and
instead of Area 51. But yeah, I'm certainly open to anyone speaking about anything vaguely technical. Completely. Right. Yeah, we normally get an update of what the local team is doing. There's a small group of young ladies who are doing some amazing technical stuff. They've had code-running on the International Space Station. They've been interviewed and published in international magazines and featured in international conferences. Remarkable doing. But John Hislop, who is their guide and mentor, is here, unfortunately. But yeah, they're amazing.
yeah, presentation.
Oh, yeah. I'm glad the story two of the week and greedy. But
About having more meetings actually.
that's brilliant. Well, let us know if he does do that. I'm sure lots of people would like to know a bit more practical electronics. Is that scout up on the way on the people's footpath? With a wingman.
Yeah,
There's lots of techie kind of geeky stuff going on in there. Not only FabLab, and Geeky, and Amateur Radio Club.
Can you say a bit more about the Geeky?
So the Geekery is a 30 square metre industrial unit on Victoria Road, in Fuller's Yard, Victoria Road, where I work, and and Mike as well.
Yeah, what you do though. Is it like
No, it's not. There are 4 desks in there. I work on one, Mark works on another, Zener works on the third, and the fourth one is still available. Working there, access to my workshop, which includes a couple of 3D printers, much smaller and less powerful laser cutters than a CNC milling machine. And the wall of joy, which is actually electronic components that people can dip into the project. Animatronic jigsaws as well, a bit of a community project. And it's Cleve's Wall. I recommend French Cleves. Come and have a look at the wall. But it's my ultimate workshop, and I want people to come there and be geekified and the expertise there, really. It's not a publicly open space. It's not big enough to be a FabLab. Have the machine. Very capable machine.
But that system,
Yeah, well, I've developed a Thanet technology is a social media that started my first Margate. So that was 2017. So it just started with meeting with jobs and then people asked us for workshops. I've done workshops on some coding things, Raspberry Pi, Arduino, a bit of electronics that I quite like. 3D print scanning, 3D printing, just and initially I thought the geekery might be the place to do that, but it's not suitable at all because it's people working the construction of doing courses and that kind of thing. Maybe. It could be done, but the Margate School is a school as well. We've been talking about maybe doing some short courses as the becomes apparent.
yeah, I think there's good work on this with something with this running. Electronics, we mentioned.
Yeah, there's a bit of electronics. I haven't quite figured that out yet. It's definitely but I am going to Mike and Samir some 3D printers so they can get in people. And because the fourth desk is free, there is a spot left on that sort of mini course. And I was going to put a ticket for that place on eBay as an auction, just to see if anyone wants to take that place and learn what a 3D workflow is. So how to make a simple design, how to slice it, and how to send it to a 3D printer. And some design tips about how to design well for 3D printing and to understand things like orientation of layers and how that works with this person. In depth there maybe. Well, probably start at £1 and £5 and if anyone bids on it. Then I'll send out a link to the eBay thing in due course. So bid hard. But that course is on the 11th of November. So it's a bit of fun. So that's what the geekery is. Much like the FabLab, but it's a bit more. It's not. It doesn't have the same number of people competing for resources.
They use the
Yeah, I'm a geek for hire, and that's my workshop.
What kind of things are you involved in?
Well, my main revenue is the defence industry, the modelling and coding. I also work for artists, like your studio partner. I'm doing some gear design, a bit of mechanical design for installation. I've done augmented reality stuff. I'm actually just doing some things with Margate School as well. I'm a jack of all trades, master of none. Really. I don't know. Stop it. So unless there's anything anyone else would like to add to this, I'll stop the recording, hang up on Lee, and I'll just put Lee on the big screen so you can all see who he's been listening to. There we go. Hello, Lee.
Hello again.
So you can just see yourself now on.
Yes.
So that's the end of the formal technology. And there are some drinks downstairs, and I think we can stay a bit longer. Other than that, thanks for coming to an in-person event.
What's the name of that YouTube channel?
That I put in the geekery. Maybe that. Oh, EEV blog. Yes, it's brilliant. There's so much brilliant stuff. I'll put this recording on YouTube. If you go to the Geekery website, I've almost got the Thanet Technology page with links to quite a lot of the, all of the most recent Thanet Technology recordings and links. And I will write up your work with the internet chip control. Not quite there yet. But all the links on the Geekery website. Get round to the geekery.uk. Oh. It's a self-steering. That's quite rude. Okay, right, Lee, thank you very much for joining, but I'm going to hang up on you, I'm afraid.
That's fine. It's been very interesting, especially about Zener diodes and having a good look around the Margate School. So thank you very much.
Lovely.
See you next time. Bye-bye.
Bye.